Hi friends, in this video we are going to study about applications of building information modeling. We will discuss about the different dimensions of BIM and the level of details. Dimensions of BIM. A building information model is inherently a three-dimensional model. However, this does not end the scope of BIM. With addition of every new piece of information, a new dimension of BIM is produced, and thus the addition of information can be endless and the number of dimensions can go to nth d. 3D, that is, involving x, y, and z axis, are the spatial dimensions. When we add time t dimension to this, we have 4D BIM. When we add C dimension, that is cost, quantity, and rates, we get the 5D BIM. Similarly, on attaching any other associated information like sustainability gives us 6D, attaching facility management gives 7D, and so on and so forth. Each of the BIM dimensions are explained more in detail in this slide. 3D models show existing condition and can be made by using scannings, ground penetration, can give us animations, give us walkthrough, and help in BIM driven prefabrication. 4D models help in project phase simulation, lean scheduling techniques like last planner just in time, and gives a visual validation for the project progress. 5D BIM is fundamental and pivotal role in estimation and cost management. It gives real time cost planning, helps to extract quantities, trade verifications, value engineering options, helps in prefabrication solutions, etc. 6D BIMS means sustainability, which combines the concept of energy analysis. It will give the sustainable element tracking and helps in lead tracking. Whereas 7D involves facility management applications throughout the building maintenance and operations stage. It involves BIM as built drawings and embedded operation and maintenance manuals of each and every equipment. As we have seen in previous video, how BIM is used throughout the project life cycle. Here, the uses of BIM in various work stages as defined by REBA is shown. That is, strategic definition, enduring preparation and brief, concept design stage, develop design stage, technical design stage, construction stage, the handover and closeout, and in use phase. Some of the key objectives, the BIM activities, and the level of detail of the BIM model can be seen here. In the strategic definition or stage 0, the key objective is to prepare the business case and strategic brief. It is also the time when the BIM strategy is laid down and its cost of implementing BIM in the project is calculated. In preparation and brief stage, data is collected for preparing models. BIM work plan and responsibility matrix is freezed. Here we get a small site model and the level of detail of that is very low. Next, in concept design stage, we actually go to prepare a 3D sketch model using massing or spatial programming. The project budget is also simultaneously prepared. Schedules are being formulated. At the end, we get a conceptual design 3D model, and the level of detail is still low. In developed design stage or the third stage, time and cost dimensions may be added to this 3D model, and further details of every component is enhanced. We get a primary design coordination model, and further can be used for 4D, 5D, and 6D workings. The level of detail here can be from medium to high. In stage 4 of technical design, same model is used to extract different types of technical and design specifications. Also, analysis like structure analysis, etc., can be carried out. The level of detail here is very high. In the construction stage, the finalized BIM model is used for off-site manufacturing as well as on-site construction monitoring. Handing over stage, the BIM model is updated to incorporate any as-built changes. Validation and testing is done. The level of detail maintained is high. Whereas in the seventh in use stage, integration of this BIM model with the building management system or BMS software is done. Then it is helpful in monitoring. The model is now federated as build or record model. Now that we have known that the level of detail in BIM changes from low, medium, high, and very high, this is called as LOD or BIM level of details. This is the nomenclature goes from 100 to 400 and beyond. Here, the first diagram shows different columns, how the design level of detail changes. In the first LOD 100, the column is represented as a concept design of only a rectangle. In LOD 200, we get to know that this column is actually a I-shaped beam. In LOD 300, the thickness and other dimensional information is added to the model. In LOD 300, we can further see the base plate and anchor bolts modeled. Whereas in LOD 400, we can see even more finer details like nut and bolt, the anchor template, etc. Similarly, for a RCC beam or girder in LOD 200, it is only a concept design showing a rectangular shape. LOD 300 shows minor cuts and offsets. LOD 350 tends to show other reinforcement details, whereas LOD 400 shows complete detail of bar bending schedule and any other material that is embedded inside the girder. Thus, we usually work on LOD 300 or 350, that is medium range of details for effective BIM use and coordination. The applications of BIM can have a range of several different functions. As discussed earlier, it is used throughout the project lifecycle. Hence, it is used for detailed design by architects, for structure analysis by the structural engineer, human analysis and solar analysis, for energy, clash detections, quantity takeoffs, to plan logistics, 4D simulation for procurement, even showing the model for marketing purposes, facility management, and also in the latest concept, BIM models are being used for virtual reality, augmented reality purposes to help construction managers even more at site during execution. Some of the major applications of BIM is quantity takeoff and cost estimation. Here, a screenshot from a Autodesk Revit model is shown. This is the structural model of a building, that is, only beam, column, slabs, foundation is modeled. Once we model a building into this detail, we can extract different types of quantity schedule. In this slide, to every element modeled in the BIM based software, its quantities are simultaneously extracted in a tabular form called as schedule in Autodesk Revit. What you see here is the RCC beam schedule, the level of where the beam is located, the structural material, the count is volume, the total volume of concrete is also calculated. Here we can see how RCC floor schedule, the floor slab thickness, its count, its volume, etc., is very clearly shown. This will give a first hand information of different types of quantities, and it will be helpful for billing, for preparing BOQ, etc. But the quantity takeoff in from a BIM model has limited applications. The quantity takeoffs of BIM is not admissible for RA bills. Though the BIM tools have the capability of extracting various details of area and volume, they cannot provide finer details in different units. For example, BIM software might provide the linear feet of concrete footing but not the quantity of reinforcement steel embedded in the concrete, or the area of interior partition walls and quantity of studs in those walls. Hence, it should be noted that while building models provide adequate measurements for quantity takeoffs, they are not a complete replacement for estimation. Therefore, by introduction of BIM, we should not think that the role of a quantity survey or estimator is completely replaced or redundant. Estimators thus perform a crucial role in the building process far beyond the extractions of counts and measurements. Next major application of BIM is 4D, which is majorly used for managing time. 4D simulations functions primarily as a communication tool for revealing the potential bottlenecks and improve collaboration. Contractors can view 4D simulations to ensure that the plan is feasible and efficient as possible. That is by looking at the logistics and the sequence of work. Communication is a major benefit of 4D model, as planners can visually communicate the planned construction projects to all projects stakeholders. Site logistics planners can manage and lay down areas access to and within the site location of large equipment trailer etc. in the model itself. This will help to prevent any kinds of accidents or clashes of vehicle movement at the site during execution phase. It also helps in trade coordination, that the expected time and space flow of trades on the site can be easily visualized. Comparing schedules of track construction project and baseline construction project gives a quick idea to see which activities are lagging behind. This is a screenshot of Autodesk Navisworks, in which a 3D building model has been fed and integrated with the project schedule. The project schedule can be prepared in MSP, Primavera, or even Excel and uploaded in Naviswork. Each of the schedule activities have to be linked with the project elements or levels. For example, the roof slab of first floor activity should be linked to the roof slab element in the model. Thus, the project duration will automatically be superimposed for that slab. Once the simulation is run, we can see the progress of the model with respect to time. BIM is also used majorly for clash detections. It is a very critical part of integrating the BIM process. That is, when different types of stakeholders and consultants like your architects, structural engineer, MEP engineers, environmental engineers work on the same model, they tend to prepare different versions of it. At the end, all these versions have to be integrated into one single model. And when we do that, clash detection comes into picture. Clash detection here is a process which identifies where the independent models clash with each other, finding the exact elements, the point of overlap, which will help the project manager to understand the design issues and immediately resolve them before it goes into manufacturing. This helps to save a lot of time. Later on, if we don't see clashes, there will be manufacturing of these components done, and at site execution can be severely affected. Thus, by using advanced 3D modeling algorithms, last minute hurdles and inconsistencies are completely eliminated from projects. Here we can see a screenshot of Autodesk Navisworks, wherein a building 3D model has been imported and the clash detection report has been run. Once this report is run, it gives a detailed list of all the clashes, the level at which it is present, its grid integration, and it will highlight those elements as you can see here. The first item shown in red, the second item is shown in green. That is, here we can see that a pipe is probably crossing wrongfully from a structural beam. Therefore, as an immediate action, the pipe level can be lowered down or it can be bypassed through some another route. BIM based simulation is also a amazing technique to observe the project timeline, a marketing tool, as well as a higher management simulation technique. Let us see how this simulation works. Here we can see two parts, that is the initial project schedule and according to the updated or target schedule or how the actual progress is going on at the site. So initially we can see that everything is going as per the planned schedule, but slowly you can observe that the target schedule is lagging behind. There are delays. The planned schedule is already in its fourth, fifth floor, while the target schedule is only in its second, third floor. Now we can see the facade works progressing, glazing, etc., being installed on one side, while the other side, the structural work is continuing. The tower crane has been dismantled, and in a period of 2 years, from January 2015 to January 2017, the project is finally completed with some delay. Thank you.